Hello guys, and welcome to part 2 of my series under module 2, which is single area OSPF configuration under the ENSA curriculum, or the Enterprise Networking, Security and Automation version 2. So let's proceed with the continuation of this module. Let's go with my PowerPoint. We are now in the point-to-point OSPF network configuration. This is part 2 of the series. So if you still remember our reference topology, we already configured the router interfaces of all the routers, router 1, 2, and 3, and we already enabled the OSPF process ID and then the router ID. And we also verified that still the 3 routers, the networks is still not yet converged. They're just communicating with their directly connected network. Like for instance, R1 and R2, R2 and R3, but they cannot communicate with other routers because they are not, the routers doesn't know about the network that is connected to another interface. Now in this topic, we're going to discuss the network command. So you can specify the interfaces that belongs to a point-to-point network by configuring the network command. So you can also configure OSPF directly on the interface with the IP OSPF. So there are 2 options. There are 2 options so that we can specify the interface in a point-to-point network. Number 1 is by the use of the network command. And the second one is using the command IP OSPF. So this is what are we going to do in order to configure and specify the interfaces that will be participating in the network. So the basic syntax for network, so let us consider first the first one, the network command. This is the general, this is the syntax. Router config router, so we are in the configuration router command. The network, and then we will use the network address, the network address in consideration, and then the wildcard mask. Wildcard mask is just the opposite of the subnet mask. And then we will specify the area. So since we are talking about the single area OSPF network, so we'll use 0 as the area. And the area ID we're going to use is also, it depends on the, since we are talking about a single area, we'll be using 0 as our area ID. So this is an interface on the router that match this part of the command, the wildcard mask. So the wildcard mask function is to match the network portion of the network address to participate in the routing, OSPF routing domain. So match this part of the command that are unable to send and receive OSPF packets. So the wildcard mask function is to match the network address that enable to send and receive OSPF packets. The area ID syntax refers to the OSPF area. So this portion of the command refers to the area. When configuring single area OSPF version 2, the network command must be configured with the same area ID value on all routers. So we have to configure the same area ID value on all routers. However, although any area ID can be used, again, this is a good practice to use the area ID of 0 for single OSPF version 2. This convention makes it easier if the network later will be altered, and it will support multi-area OSPF version 2. So it is make easier for the network administrator later on if the small network will alter. So it's easy to scale. If there's an expansion, if you're using a single area and then area 0 for one single or one group of a routers participating in the routing domain, then this is more easier for the network administrator to support scalable network if the network in consideration is expanding. All right, so this is the first network command that we're going to use later. So the wildcard mask is actually an inverse of a subnet mask, as I mentioned a while ago. And the easiest method for calculating the wildcard mask is just subtracting the network subnet mask from 255, 255, 255, 255. So in this example, we will make some corrections here in the PowerPoint. So we know that this is last 24 is actually equivalent to 255, that 255, that 255, that 0. That is the last 24 is a CIDR notation, or the classless interdomain notation. Okay, so that is the equivalent decimal value for that. Is last 24 is just we are counting the number of ones in a subnet mask to represent it as a CIDR notation like is last 24. So if we're going to subtract this one from 255, so here we will get the subnet mask. So if we're going to subtract this one, 255, from this 255, 255, 255, 255, actually this is 0, so I will make a correction here. If we're going to subtract this one, 255 minus 255, that will be 0. So this is actually written as 0 dot, and then another 0, 25 minus 0, that's 0, and another third octet, 0, dot 255 minus 0 is 255, that 255. This is the new wildcard mask. This is the wildcard mask. Okay, now for its last 26, if we're going to write this in decimal form, this is how many ones? This is 26 ones. So we'll just count 26 ones. This is 255. This is 8 ones. 255. This is another 8 ones. 255 plus 8 ones, so 24 ones. And we need still two ones. 1, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, another one. So this is the fourth octet. This is 8 ones, this is 8 ones. So 24 ones plus 2 is 26. That is why that this is last 26. So if we're going to convert this into decimal, this is the decimal positional value is 28 from right to left, and this is 64. If we're going to add this one, this 2, 128 plus 64, that will be 192. So the new subnet, this is last 26, is actually written in decimal as 25.25.25.192. So we're going to subtract this one. This is supposed to be 192. So if we're going to subtract that one from 255, this is 0, dot 0, that because 255 minus 255 is 0, dot 255 minus 192 is, this is 1, this is 15, 15 minus 9 is 6, So this is 5 minus 2 is 363. This is the wildcard mask for the subnet mask 255.255.255.192. Okay, so this is the first command using network command using the wildcard mask, the network address plus the wildcard mask, and then the area, and then the area ID. Right? This is it. So within routing configuration mode, there are two ways. Now under this mode, network command, there are two options. It's either you use network and then the wildcard mask area 0. This is the first option. The second option is you can specify the second option for first method is by the use of specifying the exact IP address, IP interface, IP version port address of a specific interface, plus using the quad 0, 4 zeros, and then the area 0. For example, in R1, the specific IP address is .5. So use that one, and then the 4 zeros, which is the quad 0 wildcard mask, plus the area 0 area, and then the area ID. And then you will be able to enable the OSPF version using the command network. The second method of enabling or configuring the router, the network in a router to participate in an OSPF routing is this one. So to configure OSPF directly on the interface, this is the second method. Use the command IP OSPF plus the process ID. The process ID, which is 10 in the IP OSPF, we use 10, and then specify the area ID. In this case, since we are using single area OSPF, we will use 0. Okay. Now, if in case you already use the first method, all you have to do is just issue the command no to remove the first command method before you can apply this method of directly configuring the network using IP OSPF command. All right. So let us use later on that one. So before we configure using the network, using this command, let us first discuss the passive interface. In passive interface, by default, what is this passive interface? By default, OSPF messages are forwarded out all OSPF enabled interfaces. However, these messages only need to be sent out interfaces that are connecting to the OSPF enabled routers. It should be those interfaces only that connecting to the OSPF enabled routers. But by default, the router is sending it out all OSPF enabled forwarded out all OSPF enabled interfaces. Like if you enable the interface of a router, definitely it will send out, it will forward messages. So to avoid this one, you should make that interface as a passive interface, because sending out, which is not needed message on a LAN, affects the network in 3 ways. If you will not make the interface as a passive, it will affect in 3 ways. Number 1, inefficient use of bandwidth. Available bandwidth is consumed transporting unnecessary message. It will make an inefficient use of resources. all devices on the LAN must process and eventually discard the messages if you send out this unneeded message. And it will increase the security risk. Without additional OSPF security configuration, the message might be intercepted with packet sniffing software. And routing updates, if that is the case, routing updates can be modified and sent back to the router, and corrupting the routing table with false metric that misdirect traffic. So those that is not actually participating in the OSPF network should make that interface as a passive interface. Like for example, what we have in our reference topology, our loopback address is actually receiving update, sending out updates. The router is sending out updates to that port. So we should make that interface as a passive interface. So what is the command to enable to make the interface as a passive interface? Just type passive interface loopback 0. In this case, we will make the loopback address interface or loopback interface as a passive because it will send out unnecessary messages. Okay, so after that, we will examine also, after configuring the network, we will examine also what type of network it's running in the implementation of that kind of reference topology. Because the OSPF point-to-point networks, by default, Cisco routers elect DR and BDR on Ethernet interfaces. In our case, we are using Gigabit Ethernet, that is an Ethernet interfaces. So what will happen there is it will elect automatically a DR and BDR by default. So you will see that DR and BDR will be elected automatically by the routers if our kind of network interface is in Ethernet interfaces. The DR and BDR election process is unnecessary as there can only be two routers in point-to-point. In the point-to-point networks, for example, between R1 and R2, doesn't need DR and BDR because they only have two routers. No need for the DR and BDR. So logically, doesn't need a designated router and backup designated router. So notice in the output that the router has designated the network type as broadcast. So if you notice this one, this is we're going to show you later. The network type is broadcast. And then the router 1 has designated the interface 2.2.2 as the designated router, and then the backup designated router is 1.1.1. Automatically, the election of DR and BDR was happened in the broadcast type network. Okay. Now, if you want to convert this broadcast so that it will not automatically elect a DR and BDR, we should convert this broadcast type network into network type point-to-point, just to avoid the automatic election of DR and BDR. Now, to change this to point-to-point network, use the interface configuration command, IP OSPF network point-to-point, IP OSPF network point-to-point. And after issuing this command, it will convert it into. After issuing this command, on the interface, IP OSPF network point-to-point, it will convert it into network type point-to-point now. So if it is converted to point-to-point, there will be no automatic election of DR and BDR. right? Now, the loopbacks and point-to-point networks use loopback to provide additional interfaces for a variety of purposes. So this is one reason why we use a loopback address or a loopback interface. By default, loopback interfaces are advertised actually by /32 as a host route. That is why we use for each octet we have 255, 255, 255, 255 to advertise this as a host route /32. To simulate a real LAN, the loopback interface can be configured as point-to-point network to advertise the full network. Just to simulate the real LAN, the loopback address that is configured in the router should be configured as point-to-point network to advertise the full network that is connected to the interface or loopback interface. Now, after converting that into point-to-point, in this case, what the router 2 sees with R1 will be /32. If you are in R2 and then you issue the command show IP route, you will notice that this is /32. Now, when you configured R1 to change interface loopback IP OSPF network point-to-point, it should result at /24. Okay, so let us go to Packet Tracer again, and let us use the command to configure the network using the network command and IP OSPF interface command. Okay, so let's go with the my okay, so let's proceed and let us apply the command. Again, enable configure terminal, and then router OSPF10, and then network. We use the first option, method 1, first option, network, and then the network ID 10.1.1. That is 0.4 network, and then that is /30. So the /30, the wildcard mask of /30 is the /30 for the sake of the /30 subnet mask. /30 subnet mask is actually, this is 255 that this is 254 at 252 because 31, so this is 824 plus 1 2 3 4 5 6 7 8 252 24 25 26 27 29 30. That is why this is /30. So if you're going to subtract this one, 255, that 255, and then subtract 255 also, 255, that 252, This is going to be 0.0.0, and then 255 minus 252 is dot 3. 255 and then 252, that is dot 3. Okay. So if we're going to configure R1 with network, the subnet mask is last 30 is actually 255.255.255. I know, sorry. Network, it should be wildcard mask 0.0.0.3, and then area 0. Okay, and another network, that is another network. So another network connected to that interface is dot 12. Okay, dot 12. Okay, and then another network is the interface, which is dot 10. This one, dot 10, dot 10, dot 1. That is dot 0, dot 10, dot 1, dot 0. Okay. So this is this network. And then the subnet mask of that is last 24. So that is 255. That's 0. Okay, the wildcard mask is 255, and then area 0. Okay, then end. Right. Okay, so this is the first option of method 1 of configuring the network. So for router 2, we'll use method 1 also, but the second option using quad 4, using the specific IP address of the router 2. So enable config T. So using the method 2, router, the command is router OSPF10, and then network. The specific IP address is for G00 is .6. So that is 10.1.1.6, and then quad 0, 1, 2, 3, 4. And then area 0. Okay, and then another interface connected to R2 is .9. So if you notice, it's already establishing an adjacency between these two interface. Full means they're already neighbor adjacency. Okay, another network is connecting is the dot 9. Then the same area, this is slash 30, so the wildcard mask is quad 0, area 0. Okay. And then the network for interface is, for this interface, dot 2 network, 10.10, and that is dot 2. This is the dot 2 network, and dot 1 is the IP address of that interface. So we change this to dot 1. All right, 10.2.1. All right, so sorry, should be end, and then we save, and our last we will use the command in the third method. We will going to use this command, the interface, and then IP OSPF10 area 0, the specific interface for router 3. Okay, method 2, enable, and then config T, and then router OSPF2 I10, and then what interface? Interface G0/0/1. That is this interface. Sorry. This interface 01. And then IP OSPF10 area 0. Okay, so another interface is this one, 00. And then we define, we include in IP OSPF command 10 area 0. Okay, see, it establishing an adjacency between R2 and R1, R2 and R3, and R3 and R1. And then the interface of interface loopback 0, and then we'll put it in IP OSPF area 10. Okay, exit or exit again. Then save. All right, so they are now develop or establish an adjacency to each other. Now we can now ping the not directly connected interface, because we already entered the network command. That means the networks are advertised to all the routers participating in the OSPF routing domain. So, for example, let us check. So if we're going to check, we're going to ping 10.1.1.9. So it will ping now. A while ago, it's not, because the network command is not yet configured. So if we're going to ping the other, which is .10 of router 3, it will also establish a success rate 100% connection. All right, now 3 routers now enabled. The router OSPF now in area 0, single OSPF, now communicating to each other, except the internet. We're not yet configured this one. We will configure that one on the next topic. So we're done with here. So if we're going to use this, if we're going to convert the loopback, we will make the loopback address as a passive interface. So for example, in our router 1, we will make a loopback as a passive. Let's say, let's do it in router 1. Let's check first. We are in router 1. Show IP protocols. So these are the routing. They are the routing information, the gateway, the router ID. Okay, using the show IP protocols. The interface, loopback interface is not yet passive. So if you're going to configure that one, config the router OSPF 10 passive does interface loopback 0. Okay, and show IP protocols. Now it shows now that the loopback address of this router 1 will become passive interface. Loopback passive interface now. The loopback now is in passive interface status.